to make you to understand your concept within 10 minutes, so that you can able to spend less time but get more marks. Right. So the topic for today is about acid-base disorder in a 3-step. Okay, you can able to answer those type of questions which is related to the acid-base disorders. Like the question will be given to you, a patient who had an arterial blood gas analysis. So the pH of that patient is like this, partial pressure of carbon dioxide is like this. So what is this type of analysis? Maybe they give metabolic acidosis, metabolic alkalosis, respiratory acidosis, respiratory alkalosis as an option for you, and they may ask you sometimes what is the compensatory mechanism of this. For those type of MCQs, you have to know some facts and concepts related to this acid-base disorder. Just before we enter into the MCQs, just know some normal laboratory values. So in arterial blood gas analysis, the pH of the blood is around 7.35 to 7.45. Also, you have to know the partial pressure of carbon dioxide. Partial pressure of carbon dioxide is around 35 to 45. Just very easy, right? So this is 7.35 and partial pressure of carbon dioxide is 35. 7.45 partial pressure of carbon dioxide is 45. Right? Millimeter mercury. And number 3, partial pressure of oxygen is around 80 to 100 millimeter mercury. And number 4. Number 4th one is level of bicarbonate. Normal level of bicarbonate is around 22 to 26 milliequivalent per liter. So these are the 4 important values you have to know to answer those type of MCQs. This is very important. Without this, you cannot able to answer those type of questions which are asked in acid-base disorder topic. Right. So once you know this topic, once you know the fact, so then you can able to analyze those type of questions and able to answer within a 3 steps. Very easy, right? So normally the student will be very confused about this topic, but I just trying to understand within a 3 steps so that you can able to get 100 out of 100 marks in this particular topic. Right. So step 1. Step 1 is, if a question is given to you and you have to check the pH of the particular arterial blood gas analysis. So we studied about now the pHs, normal pHs around 7.35 to 7.45. Right. And if the pH is less than 7.35, it is called as acidosis. Right. So this is the first step. And if the pH is more than 7.45, it is called as alkalosis. So first we have to be check whether the patient is having acidosis or alkalosis. Once you confirm this is an acidosis or alkalosis, the next step, the second step which you have to go for, you have to tell, you know the patient is having acidosis or alkalosis. So coming to the step 2, you have to tell whether the patient is having metabolic acidosis or respiratory acidosis, or metabolic alkalosis or respiratory alkalosis. How to tell? So first check about pH, right? So this is the first step. So if the pH is less, then you can tell acidosis. This is the first step. Then go for the second step, partial pressure of carbon dioxide. If it is also less, then you can say the patient is having metabolic acidosis. And if the pH is less, now you can tell acidosis. But if the partial pressure of carbon dioxide is higher, you can tell respiratory acidosis. Are you able to understand what is the difference? Yes, good. Just check this first box. So both arrow in the same direction. If the arrow is in the same direction, it is metabolic. If the arrow is in the reverse direction, it is respiratory. Okay. So just remember this mnemonic. Same. ME for metabolic. Okay. Reverse. If the arrow is in the reverse, RE for respiratory. So if the arrow is in the same, it is metabolic. If the arrow is in the reverse, it is respiratory. So this is what you have to know in the second step. Very easy, right? Coming to the third step. So we have four phenomena. Number one, metabolic acidosis. Number two, metabolic alkalosis. And number three, respiratory acidosis. And number four, respiratory alkalosis. Right. So what is the compensatory mechanism of this four process? Metabolic acidosis is compensatory by the opposite. Acidosis. What is the opposite for acidosis? Is good. Alkalosis, metabolic, respiratory. So the compensatory mechanism for metabolic acidosis is respiratory alkalosis. Now tell me what is the compensatory mechanism of metabolic alkalosis? Alkalosis, compensatory mechanism, acidosis, metabolic, respiratory. Yeah, good. Compensatory mechanism of respiratory acidosis. Acidosis opposite, alkalosis, respiratory opposite, metabolic, alkalosis opposite, acidosis, and respiratory opposite, metabolic, right? So this is the simple way to answer for the compensatory mechanism. So it is just three steps. So we have a four process: metabolic acidosis, metabolic alkalosis, respiratory acidosis, respiratory alkalosis. So the first step, we have to know the pH. If the pH is less, we can tell the patient it is an acidosis. The pH is more, alkalosis. Second step, we have to tell whether it is metabolic or respiratory. The third step, we have to tell the compensatory mechanism. So right. Now coming to the last one. Now you can able to understand within this three-step process. Now tell me the pH is less in the first and second column. The pH is less. Now you can able to write it is an acidosis. Right? Now tell me whether it is a metabolic acidosis or respiratory acidosis. Both arrow in the same direction. If the arrow is in the same direction, it's metabolic. If the arrow is in the reverse direction, reverse, RE, respiratory acidosis. Good. Again, pH is higher in the second, third and fourth column. So here, because the pH is higher, you can tell it is an alkalosis. Right? Again, both are in the opposite direction. The arrow in the opposite direction. So if arrow in the opposite direction is reversible. So respiratory alkalosis. If arrow in the same direction, say metabolic alkalosis. Right. Now you know what condition it is. And the last step is about the compensatory mechanism. So acidosis compensatory mechanism, alkalosis. Metabolic, respiratory. Compensatory mechanism for metabolic acidosis is respiratory alkalosis. Respiratory acidosis. Compensatory mechanism, metabolic alkalosis. Just opposite. Compensatory mechanism, metabolic acidosis. Compensatory mechanism for metabolic alkalosis is respiratory acidosis. So now, for any type of question given to you for an arterial blood gas analysis, you can able to understand and you can able to answer and get it full mark, right? And in case the patient is having respiratory alkalosis, the carbon dioxide is less, right? So now to have that idea, we can able to answer some of the multiple choice question, right? Can you just put those MCQs, right? Coming to this first MCQ. So whatever the question given to you, your eyes have to first thing go to the pH. So the pH is 7.1. Mean normal. What is the normal pH? Normal pH is around 7. The normal pH is around 7.35 to 7.45. But the pH which is given to you is around 7.1. So the pH is less. So because the pH is less, you can able to tell the patient is having acidosis. So this is the first step. Right? So second step, the pH is less. The second step, you have to see about the partial pressure of carbon dioxide. So the partial pressure of carbon dioxide is 16 millimeter mercury. What is the normal partial pressure of carbon dioxide? 35 to 45. So partial pressure of carbon dioxide also decreased. So both arrow in the same direction. If the arrow is in the same direction, you can go for what? Metabolic acidosis. So what is the answer for this? Answer for this is first option, metabolic acidosis. Here they not ask you anything about compensatory mechanism, so you can able to skip out. Right. Coming to the second question. Again, we have to go through the pH of the question. So pH is 7.55. So pH is more than normal, mean higher than normal. Okay, so we can tell the patient is having alkalosis. Now we have to tell whether it is in metabolic or respiratory alkalosis. So go for the partial pressure of carbon dioxide. Partial pressure of carbon dioxide normal level is 35 to 45. So here it is given as 52. So partial pressure of carbon dioxide also increased. So both are in the same direction. So answer for this is metabolic alkalosis. Okay. The second step itself you can able to answer. So answer for this is second option, metabolic alkalosis. Right. So coming to the third question. So the patient of arterial blood gas analysis, the pH is around 7.5. So pH is increased. So it is alkalosis. But what about the carbon dioxide partial pressure? Decreased partial pressure of carbon dioxide. So both arrow in the opposite direction. Opposite direction. So come we can go for respiratory alkalosis. So fourth option. Right. So coming to the last one. A patient with salicylic acid poisoning, like pH of 7.12. Okay, so pH is less than normal. pH is less than normal. Partial pressure of carbon dioxide is 18 millimeter. So again, partial pressure of carbon dioxide is decreased, right? So both are decreased. So it is an acidosis. First step, because both are decreased, we can go for metabolic acidosis. So answer for this is, so either you can go for the first option or second option. Okay, you can skip it out the third and fourth option because the arrow is in the same direction. So metabolic acidosis. Second option also metabolic acidosis. What is the compensatory mechanism of metabolic acidosis? Acidosis opposite alkalosis. Metabolic opposite respiratory. So answer compensatory mechanism is respiratory alkalosis. So second option also you can skip it out. So go for the first option. So the answer for this question is metabolic acidosis with respiratory alkalosis. Hope you can able to understand the arterial blood gas analysis of the question which asked to you. So probably this is one of the very important topic you can expect in your competitive exam. Thank you for watching.